Luis Alvarez was a Nobel Prize-winning physicist, probably most famous for the discovery of the Iridium layer and his theory that the mass extinction of dinosaurs was caused by an asteroid or comet colliding with Earth. Besides doing the normal work you might expect of a physics professor, Alvarez took on more unusual projects, like making use of cosmic rays to search for hidden chambers in an Egyptian pyramid. Early life and education. Luis Walter Alvarez was born on June 13, 1911, in San Francisco, California. His father, Walter Clement Alvarez, was a doctor and author who wrote a large number of medical books.
Now continue.
I will.
His mother was Harriet Smith.
Why do we have to learn this?
Luis began his education in San Francisco, first at Madison School, then at San Francisco Polytechnic High School. In 1926, when he was 15, his father changed jobs and the family moved to Rochester, Minnesota. Luis graduated from Rochester High School, then started a Bachelor of Science course at the University of Chicago in 1928, intending to major in chemistry. After a couple of years, his grades in chemistry were not as good as he had hoped. He was scoring B's.
Congratulations.
Also, he had also grown much more interested in physics, so he decided to major in physics instead. He graduated with a BS in physics in 1932, then continued as a graduate student at Chicago, where he was awarded a master's degree in 1934, and a PhD in physics in 1936. Even at the beginning of his time as a graduate student, Luis Alvarez was at the cutting edge of physics. His doctoral advisor was Arthur Compton, winner of the 1927 Nobel Prize in Physics for his discovery that electromagnetic radiation, such as visible light, has particle-like properties. In 1932, Alvarez built an array of Geiger counters to study cosmic rays. In 1933, using the data he had gathered, he and Compton published a paper in the Physical Review establishing that cosmic rays are positively charged particles. Compton gave much of the credit for the work to his young graduate student. After completing his PhD in 1936, Alvarez returned to his home state, beginning work as an experimental physicist at the University of California's Radiation Laboratory in Berkeley. Luis Alvarez's scientific achievements. Luis Alvarez was a highly talented and highly imaginative experimental physicist. He had a particular talent for devising experiments that asked questions in such a way that Mother Nature felt compelled to give a good answer. Some of his achievements were establishing K-electron capture. One of the ways radioactive atoms transform into new elements is capture of an orbiting electron by the nucleus. The electron combines with a proton to form a neutron. The atom now has one proton fewer than it used to, and so has become a new element. This process had been predicted by theorists but never observed. In 1937, Alvarez devised a new experiment to ask Mother Nature whether the process really happened. He looked for the X-rays expected to be emitted by a nucleus when it captured an electron. The experiment worked and K-electron capture became an established phenomenon in physics. The cyclotron. Alvarez spent a lot of time at Berkeley working with the cyclotron, particle accelerator, atom smasher. He was able to prove that helium-3 is stable, although it had been predicted to be unstable. Air safety improved by ground-controlled approach. Alvarez was an enthusiastic pilot. He learned to fly in 1933. In the early 1940s he invented the microwave phased array antenna. This was a form of radar that gave ground crew unparalleled precision in determining the position of an aircraft in flight. The invention allowed ground crew to give clear instructions to pilots as their aircraft approached runways preparing to land.
Powering up the cyclotron, energy output
The
rising,
system was
atomic structure is
particularly
stabilizing,
useful
perfect
when
visualization.
visibility was poor,
Initiating
such
sequence
as in
now.
fog
Containment
or
is
other
stable.
adverse weather,
Power
or when
rising,
pilots
confirmed.
were inexperienced.
Target incoming. bearing
Alvarez's
030.
invention
Confirmed.
was
Speed
used
increasing.
by the
Go lock.
military
Locking on.
and
Range
civil
closing
authorities
fast.
in
Clear for
various
base.
countries
Runway
for
is cleared.
decades,
Cleared for takeoff.
greatly enhancing air safety.
Rotate. Positive climb.
Detecting nuclear
Runway 27,
weapons
cleared for
projects.
takeoff.
In
Wheels up,
1943,
contact departure.
during World War II, Alvarez was asked if it would be possible to tell scientifically if Germany had its own atom bomb
Gentlemen, the window is
project.
closing. We move now.
He
Sir,
knew
supply
that
lines are
research
strained.
and
We need air
development
cover.
into
We'll
atom
have it. Make
bombs
it happen.
produces radioactive
The eastern flank is
gases,
exposed.
such as
Can we shift reserves from the north? That would weaken
XENON-133.
the center. We have no choice.
These gases could be detected with the right equipment, and Alvarez was an equipment expert. He said aircraft should fly over Germany carrying radiation detectors to detect the telltale gases. The flights took place and found no evidence Germany had an atom bomb project. Alvarez's method was used after the World War II to detect atomic research taking place around the world. The atomic bomb. In 1944, Alvarez arrived at Los Alamos, New Mexico, to work on the Manhattan Project. There he devised an electrical detonation method for the plutonium bomb.
Check engine pressure.
He
Pressure
and his
steady.
graduate
Increase
student
throttle to
Lawrence
60.
Johnston
Throttle
also
to 60
designed
monitor.
equipment to measure the energy released by a nuclear explosion. The two scientists flew in an observation aircraft to Japan when the bombs were dropped to measure how powerful the nuclear explosions had been. The hydrogen bubble chamber, discovery of new subatomic
Readings confirm
particles,
the
and the
anomalies
Nobel
accelerated.
Prize.
I see it. Adjusting the parameters now.
When the
Good.
war
Monitor
was
the feedback
over,
closely.
Luis Alvarez moved back to Berkeley as a full professor. He was soon busy again with experimental physics. It was an exciting time to be in particle physics, and the atom smashers at Berkeley made it an ideal place for new discoveries. When Alvarez
Field
first
alignment
went
looks
university,
good. Confirmed.
only
Beam is
two
stable.
fundamental
Let's
particles
log it
had
and
been
proceed.
known: the proton and the electron. By 1932, the year he completed his degree, the horizons of particle physics had widened greatly with the discovery of two new particles: the neutron, discovered by James Chadwick, and the positron, discovered by Carl Anderson. Further discoveries, K-mesons and hyperons, expanded the particle world in the late 1940s, and by 1950 the pion family of particles had become known.
We have to be
These
careful.
discoveries
If word gets out,
relied
we're
on a
finished.
device
What do
called
you
the
suggest
cloud
we do?
chamber,
We act
in
now
which
before it's too
subatomic
late.
particles
Look
left
closely.
vapor
This is the
trails.
key. It's just a sketch.
One
It's
day
more
in
than that.
1953,
Trust me. All right,
Alvarez
show me.
got talking to a young physicist. The young man was Donald Glaser. Over a meal at a conference, Glaser told Alvarez about his new invention, the bubble chamber, which was an improved way of tracking subatomic particles. Glaser would go on to win the 1960 Nobel Prize for this invention. Alvarez thought about what Glaser had told him. Glaser had used a bubble chamber filled with liquid ether. Alvarez decided that a bubble chamber filled with liquid hydrogen would be a perfect way of tracking particles coming out of an accelerator. The idea was that the liquid hydrogen would boil
Look, the vapor
wherever
is
a high-energy particle
The core is
passed through it,
destabilizing. We need to
leaving
monitor
a
this.
trail whose path would allow the
Initiate
particle's
activation
properties to
sequence,
be
monitor all
calculated.
levels. Levels are stable. Core
By
is
early
responding. Good. Watch the
1954,
fluctuations.
Alvarez
These
had put
patterns
together
match the
a
ancient
small-scale
maps, and the
liquid
bubbles
hydrogen
could be
bubble
seals.
chamber at
We need to
Berkeley.
document this. Here are the newly identified
By
particle states coupling to the
1956,
H5 field.
a
And this
large
equation shows their
chamber
energy
was in
levels from our
operation.
resonance model.
In the late
I believe this
1950s,
proposal
this
merits serious
chamber was
consideration.
used to discovery a variety of new particles and resonance states. Alvarez was awarded the 1968 Nobel Prize in Physics for the work he and his group carried out. His prize award was for his decisive contributions to elementary particle physics, in particular the discovery of a large number of resonance states, made possible through his development of the technique of using hydrogen bubble chamber and data analysis, using radiation from space to search for pyramid chambers. In 1967, Alvarez had the ingenious idea that hidden chambers in Egypt's pyramids could be revealed by making use of cosmic rays to take a X-ray type photo. He placed a cosmic ray detector in an existing chamber below in the Pyramid of Chephren, the second largest of the pyramids of Giza. The rate that cosmic rays arrived at the detector would reveal any spaces within the pyramid structure. Alvarez was able to study about 1/5 of the pyramid's volume, but found no new chambers. Dinosaur death by meteorite. Alvarez's son Walter, like his father, had become a scientist.
Look here. This passage changes
Walter was a geologist, and one day in 1977 he decided to tell his father about a problem he had. His problem was called the KT boundary, a gray-colored layer of clay found in rocks. This clay layer was unusual, because it was found all over the world, and it was the same age everywhere, meaning the layer had been made all over the world at exactly the same time 65 million years ago. And even better, from Luis's perspective, because he loved scientific puzzles, was that below the layer you could find dinosaur fossils in the rocks, but above the layer there were no dinosaur fossils. Dinosaurs and many other life forms that existed before this layer of clay was formed were extinct afterwards. This was not a new problem. The boundary and the change of lifeforms on either side of it were noticed in Paris in the early 1800s by Georges Cuvier, who proposed that some catastrophic event had caused the clay layer. However, Cuvier's ideas became unpopular because the new science of geology was governed by the uniformitarianism doctrine, the belief that all changes in the Earth's geology happen gradually. After discussing the problem, father and son started off with a rather modest goal. They wanted to determine how long it took for the 1 centimeter deep layer Walter had been investigating in Italy to form. Luis decided the best way to do this would be to measure how much of the chemical element iridium was present from the top through to the bottom of the layer.
Observe this critical term here. It directly impacts the entire equation. This changes everything.
Comes mainly from meteorite impacts, and Luis had calculated the average amount of iridium that arrives on Earth each year from meteorites. Comparing iridium levels in the layer with typical iridium arrival rates would tell him how long it took for the layer to form.
Could this be the breakthrough?
Luis asked Frank Asaro, a nuclear chemist at the Lawrence Berkeley Laboratory, to determine the iridium content of samples of gray clay from the KT boundary layer. Asaro and his nuclear chemist colleague Helen Michel found much higher concentrations of iridium in the samples than anyone could have imagined, much more than could be explained by the normal number of meteorite impacts. In 1980 the team published their evidence and stated their belief that the KT boundary layer and the mass extinction event had been caused by a massive meteorite impact. Luis Alvarez calculated a 10-kilometer diameter meteorite traveling at 25 kilometers per second hit Earth 65 million years ago. The impact sent a huge volume of rock dust into the atmosphere, which eventually settled to form a thin gray layer all over the world. While the dust was in the atmosphere, it blocked the sun's rays, putting a stop to photosynthesis and cooling the planet. Without food and heat, the dinosaurs died out. Most paleontologists were unconvinced by Alvarez's explanation of the mass extinction's cause. It is fair to say that the debate between paleontologists and supporters of the Alvarez theory was fierce and raw. There was a large amount of ill feeling in the opposing camps, not helped, it must be said, by Luis Alvarez himself. Alvarez was generally cantankerous and dismissive of anyone with a view different from his own. In 1990, 2 years after Luis Alvarez's death, the Chicxulub Crater in the sea off Mexico's Yucatan Peninsula came to the attention of geologists, who agreed that the profile and age of the crater matched the Alvarez predictions. The meteorite impact itself is no longer a topic of debate. It is completely accepted that Alvarez's team was right about this. Whether the mass extinction was caused mainly or exclusively by the impact is, however, still debated. The end. Luis Alvarez died of cancer of the esophagus at the age of 77 on September 1, 1988. He was survived by his first wife Geraldine Smithick, and their children Walter and Jean, and his second wife Janet Landis, and their children Donald and Helen.